Hi everyone, Monisha here. I hope you understood the introductory part of complex numbers and quadratic equation chapter. So in this video, I have come up with the first 7 exercise problems. That is exercise 5.1 from question 1 to question 7. I'll be going to solve in this section. So in this exercise, there's a total of 14 questions. So in this episode, I will be completing the first 7 questions of it. And in my upcoming videos, I will be completing all the other problems. So please stay till the end so that you can understand all the concepts of the problems easily. So let us go into the session. Moving on to the first question of exercise 5.1. The question is, express the given complex number in the form a plus ib. So we have to interchange and solve this complex number into the form a plus ib. Okay. So here the question is 5i into minus 3 by 5i. So we need to interchange it in that form so that to bring it down in the form of a plus ib. Okay. So first I will be taking this minus here. So minus 5 into 3 by 5. So I will be taking numbers first. Minus 5 into 3 by 5 into the two i's are there. So I into I. Okay. So here 5 get cancels. The remaining is minus 3. Here I into I will become I square. So from the introductory part, we know that the value of I square is equal to minus 1. So this will become minus 3 into minus 1. So minus into minus is plus. So it will become 3 into 1, 3. So we have to convert it into a form of a plus ib, since the real part, we obtain the real part. Okay. So that we can write it as 3 plus 0i. If the imaginary part is not there, means we can include a 0 here. So 3 plus 0i. So we need to express this equation in the form of a plus ib, that is a plus ib. Okay. So this is the easiest way of solving the problem, and this main is also an easier one. I hope you understood this. Let us move on to the second question of this session. So here again, we have to express the complex number in the form a plus ib. Here the question is I to the power of 9 plus I to the power of 19. So we need to split the powers first. Okay. So we need to split the power so that we can solve it easily to bring it down in the form of a plus ib. Here the number 9 can be split in the form 4 into 2, 4 2s are 8 plus 1 is 9. So 4 2s are 8 plus 1. So why we are taking this 4 first, I will tell you later. Plus here 19 is there. So here 4 4s are 16. So 4 4s are 16 plus 3 is 19. Okay. So why we are taking a4 means every fourth power of I is equal to 1. So how it came? We know that I square is equal to minus 1. So we know the value of I square, right? I square is equal to minus 1. So I square into I square. Okay, a to the power of m into a to the power of n is equal to a to the power of m plus n, that is 4. So 2 plus 2, 4. So we know that I square is minus 1 into I square is minus 1. Minus minus get cancels, 1 ones are 1. So every fourth power, therefore every fourth power is equal to plus 1. So I4 is equal to plus 1. So next we have to interchange it into the form of a to the power of m into n. Okay, so this will be in the form first a to the power of m into a to the power of n. So that is a to the power of m into a to the power of n will be in the form of a to the power of m plus n. Okay, so this is the formation of it. A to the power of m into a to the power of n will be a to the power of m plus n, that is 2 plus 2, 4. Okay, so another one formula is there. So a to the power of m whole to the power of n. So a to the power of m whole to the power of n is equal to a to the power of mn. A to the power of m whole to the power of n is a to the power of mn, m into n. Okay, so here I will be taking it to that form. So 4 2s are 8. So I to the power of 4 whole to the power of 2. It is nothing but 4 2s are 8 and 4 2s are 8. We have to multiply it. Plus 1 is there. Okay, so I will be taking just plainly a I. I is nothing but I to the power of 1. So this will become I to the power of 8 plus 1. So this is in the form of a to the power of m into a to the power of n. So a to the power of m plus n. So 8 plus 1 will be 9. So we will be taking down this 9 into a split form. Okay. In the same way, here we have to write I to the power of 4 whole to the power of 4. That is a to the power of m into n form into I to the power of 3. Here 3 is there. So this will become 4 4s are 16. 16 plus 3, 19. So this whole formation will become I to the power of 19 and this will become I to the power of 9. Okay. So next, from complex equations, that is the power of I. The power of I concept tells you that I to the power of 4 is always equal to 1. So I to the power of 4 is equal to 1 and this is a square here. Okay, square into I. I to the power of 1 is nothing but I. Any number to the power 1 always retains the same number. Okay. Here I to the power of 4 is 1 to the power of 4 into I cube. Okay. So next is I square, 1 square. So 1 square is nothing but 1 itself. Here 1 into I plus 1 to the power of 4 is always 1 into I3 is there. Okay. I3 can be written as I square into I. So I square into I is nothing but 1. So a to the power of m into a to the power of n is a to the power of m plus n. That is a3, right? I3. So I square, we know that the value of I square is minus 1. So minus 1 into I to the power of 1 is I itself. So I into minus 1 is minus I. So these things you have to keep it in mind. Okay. First one is I square is always equal to minus 1. I cube is always equal to minus I. And I4 is always equal to 1. I square minus 1. I4 plus 1. I3 minus I. Okay. So this I to the power of 3 will become minus I. So next, I into 1 is I. Here I into minus 1 is, 1 into minus I become minus I. So plus I minus I get cancels. So it will become 0. So we can write it as 0 plus 0I. Okay. So this is the way of solving the equations. So if you know the power of I, then you can easily solve it. I hope you understood this. Moving on to question 3rd. Here we have to express the complex number in the form of a plus ib. Here the question is I to the power of minus 39. In the previous problem itself, I have told you that I have to be converted in the form of I to the power of 4 so that the problem becomes easier for us. Okay. So first we need to convert this I to the power of minus 39 into a split form. So here minus 4 into 9. So we write it here. Minus 39 can be written as minus 4 into 9. Minus 4 into 9 is 9 4s are 36. Minus is there, so it will become minus 36. Okay. So it will become minus 36. Next here minus 39 is there, so we can add minus 3. So minus 4 into 9 is minus 36 minus 3. Like signs we need to add. So minus into minus is plus. 36 plus 3 is 39. And larger number retains the sign. Larger number sign is minus, so it will become minus 39. So minus 39 can be split into a form of minus 4 into 9 minus 3. Okay. Minus 4 into 9 minus 3. So this is the way of splitting it. So next we have to introduce this formula, that is a to the power of m into whole to the power of n is a to the power of m into n. So now this is in the form of a to the power of m into n, where I will take it back into its previous form, that is a to the power of m whole to the power of n. So this will become I4 whole to the power of minus 9. So I will be taking I4 because we know that every fourth power, okay, I4 is equal to 1. So I4 whole to the power of minus 9. Again it will become m into n, that is 9 4s are 36 itself. Next minus 3 is there. I will take it to a form of I to the power of minus 3. Okay, because we know that a to the power of m into a to the power of n is equal to a to the power of m plus n. So this whole equation is in the form of a to the power of m plus n. Here it minus is there, m plus n. So we can split it a to the power of m, a to the power of n. Okay. So now we know that I4 is equal to 1. So this will become 1 to the power of minus 9 into here I to the power of minus 3. So this is in inverse case. So inverse means 1 inverse is also equal to 1 by 1. In the same way, 1 to the power of minus 2 is equal to 1 square. So here 1 to the power of minus 9 is there. We can write in the form of 1 by 1 to the power of 9 into I to the power of minus 3 can be written as 1 by I to the power of 3. So from the powers of I, we know that I square is equal to minus 1, I cube is equal to minus I, and I4 is equal to 1. Okay, here I cube is there, which is equal to minus I, and 1 to the power of 9. So 1 to the power of any infinite number will become 1 itself. So here it will be 1 by 1 into 1 by minus I. I3 is equal to 1 by minus I. So this will become 1 by minus I itself. Here this I can be shifted if in numerator or denominator. If it is in the fraction form, the sign can be shifted to numerator or denominator. So we can write it as minus 1 by I. After this case, you can't continue the problem. So in this case, what you have to do is you need to rationalize or multiply and divide throughout by I itself. Okay. So here minus 1 into I will become minus I, divided by I into I is I square. Okay. Minus I divided by I square. The value of I square is minus 1. Okay. Here minus minus get cancels. The answer is I. So I is nothing but 1 I. Okay. So we can write in the form of, here imaginary part is there but real part is not there. So if real part is not there, we can take it as 0 plus 1 I. So this is the way of reducing I to the power of minus 39 into the form of a complex number, that is a plus ib. I hope you understood this. Moving on to the fourth question. This is somewhat a simple problem. So the question is 3 into 7 plus I7 plus I into 7 plus I7. So this is in the multiplication form. So we can directly multiply it. So 3 7s are 21 plus 3 into I into 7. Okay. So 3 7s are 21 and I is there. So we can write 21I plus 7 into I is 7I plus here nothing but it is 1I. So 7 ones are 7 and I into I is I square. Okay. So next is write down 21 as it is plus 21I plus 7I will become 28I plus 7 into, we know that the value of I square is equal to minus 1. So we can substitute minus 1 in the place of I square. So here this will become 21 plus 28I. Here 7 into minus 1 is minus 7. So we can write 21 minus 7 plus 28I. 21 minus 7 is 14 plus 28I. So 14 plus 28I is in the form of a plus bi or a plus ib in a complex form. Okay. So this is the way of reducing it into a complex number form. I hope you understood this. Let us move on to the fifth question and the simplest problem of this session. So the question is 1 minus I minus of minus 1 plus I6. Okay, so we have to reduce it into the form of a complex number, that is a plus ib. Here 1 minus I, minus into minus it is plus, so it will become plus 1, minus into plus is minus 6I. Okay, next I will be grouping it, the number to one side and the complex number to other side. So 1 and plus 1 minus I and minus 6I. Okay, so 1 plus 1 is 2. Here minus into minus is like signs means we have to add it. So 6I plus I will become 7I and the larger number sign is minus here. Okay, so 2 minus 7I, which is in the form of a plus bi, where a is, the real part is 2 and the imaginary part is minus 7I. Okay, so this is the way of reducing it into a form of complex number. I hope you understood this. So let us do the sixth question. So the question is 1 by 5 plus I into 2 by 5 minus 4 plus I into 5 by 2. Okay. So first we have to take it out from the bracket since minus symbol is there. So 1 by 5 plus I 2 by 5 minus into plus is minus 4, minus into plus is minus I 5 by 2. So next we have to group the real part to one side and the imaginary part to other side. So here it will become 1 by 5 minus 4. Okay. So next is plus I 2 by 5 minus I 5 by 2. Okay. So 1 by 5 minus 4 plus I 2 by 5 minus I 5 by 2. So 1 by 5 minus 4 by 1 plus here I is common, so I'll be taking it out. Remaining is 2 by 5 minus 5 by 2. So here the LCM is 5. So 5 ones are 5, 1 into 1 is 1 minus 1 5s are 5, 5 into 4 is 20. Okay, so plus I you have to write as it is. Here 5 and 2 is there. The LCM of 5 and 2 is 10. So if you don't know how to find out the LCM, I will write it here. Okay, so 2 ones are 2 and 5 ones are. Okay, here whatever is there, you have to just multiply it. 2 5s are 10. So this is the way of finding out the LCM. Okay, next, so from the denominator of the first fraction, you need to divide it. Okay, 5 2s are 10. Then whatever quotient you obtain, you have to multiply with the numerator. 5 2s are 10 and 2 into 2 is 4 minus 2 5s are 10, 5 5s are 25. Okay, I hope you understood this, how to do the LCM part of it. So next is 1 minus 20 or 20 minus 1 is 19. So larger number is 20 and the sign is minus here. So minus 19 whole divided by 5 plus I write down as it is. Here 25 minus 4. 25 minus 4 is 21. Since larger number is minus, has minus sign, so retain that minus sign here. Whole divided by 10. Okay, so this becomes minus 19 by 5. So plus into minus is minus. So minus I into 21 by 10. So this is in the form of A plus IB, where A is minus 19 by 5 and B part is minus 21 by 10. Okay, I hope you understood this. Moving on to the 7th question of this session. Here the question is 1 by 3 plus I 7 by 3 plus 4 plus I 1 by 3 minus of minus 4 by 3 plus I. So first we have to take it out from the bracket. So we can write it as 1 by 3 plus I 7 by 3 plus is there. So we can write it directly plus 4 plus I 1 by 3. Minus into minus is plus 4 by 3 minus into plus is minus I. Okay, so after taking out from the bracket, we have to separate it into a group. So the real part to one side and the imaginary part to other side. Okay, here 1 by 3. So 1 by 3 plus 4. 4 nothing but 4 by 1 and plus 4 by 3. Okay, so these three belongs to the real part, plus here I is there. So I will be directly taking I as common. So I, here it is 7 by 3 and here it is 1 by 3 and here it is minus 1, nothing but minus 1 by 1. Okay, so first we have to take it out from the group, then we have to separate it in the form of a real part and the imaginary part. Okay, so next step is to take the LCM. Here 3, 1 and 3 are there in the denominator, therefore the LCM is 3 itself. Okay, if you take 3, 1 and 3, all the denominator of it. So 3 ones are 1 as it is and 3 ones are. So what is the thing remaining here? 3. So the LCM will be 3 itself. Okay, so next, from the denominator of each fraction, we have to divide the LCM. So 3 ones are 3. So that quotient multiply to the numerator. So 3 ones are 3. 1 into 1 is 1 itself. Plus here 1 3s are 3. 3 4s are 12. Plus 3 1s are 3. 1 4s are 4. Okay. So this is the way of doing the LCM part. Plus here also 3 and 1 is there. Again the LCM is 3 itself. Okay. So 3 1s are 3. 1 into 7 is 7. Plus 3 1s are 3. 1 1s are 1. Minus 1 3s are 3. 3 1s are 3. Fine. So next. So here the numerator, we have to add all the elements in the numerator. 12 plus 1 13. 13 plus 4 is 17. Okay. 17 divided by 3. Plus I into, here 7 plus 1 is 8. 8 minus 3 is 5. Into 5 by 3. So this is in the form of A plus IB, where the real part A is 17 by 3 and the imaginary part that is equal to 5 by 3. Okay, I hope you understood this. So the 7th question was the last question of this session. If you have any doubts, kindly comment me on the comment section. Thank you. Thanks for watching my videos.